Hello, and thank you for viewing our memory test video. Casio specializes in the verification and test of embedded systems. In this short video, we're going to present a test strategy and utilize that test strategy to quickly locate a memory error. Let's get started. Let's take a moment and review the test setup. We'll be using a Panda board which is based on TI's OMAP4 processor, and we'll be using two of those boards. The first Panda board exhibits a memory error, and the second one does not. Each Panda board will be running a VTOS. VTOS is Casio's special purpose operating system for verification and test. VTOS will be communicating to a laptop which is running Integration Workbench. Integration Workbench acts as a user console, providing a test menu as well as a command line interface to VTOS. As I mentioned, the Panda board is based on a TI OMAP4 processor. This is a block diagram of the development board that we'll be using as our device under test. As you can see, we have MIPI, audio, camera, HDMI, etc. Casio offers functional tests for each of these blocks, but in the case of this video, we're going to focus in on the memory. The test process will be driven through Integration Workbench, which acts as a user console. From here, you'll have access to a test menu as well as a command line interface to VTOS. Functional tests are run with the click of a mouse button by selecting them from the test menu. From the command line, you can read and write memory, peek and poke hardware, access and configure connected devices, load and execute code and tests, as well as create and execute custom test scripts. As I mentioned, Integration Workbench provides the user with a test menu. Here's a screenshot of the user manual covering the SD-RAM tests. As you can see, there are 10 different tests covering data, address, memory, and burst modes. The tests can be run on an individual basis with the click of the mouse, and they also come pre-packaged in terms of a quick test as well as a complete test. With scripting, the user also has the option to pick and choose both the test and the sequence to run. Let's take a moment and review the test setup. We'll be using a Panda board with 4 processor, and we'll be using two of those boards. The first Panda board exhibits a memory error, and the second one does not. Each Panda board will be running a VTOS.
Thanks, Bob. Casio's Integration Workbench gives you an easy way to control your hardware and access the appropriate functional tests for your system. You can use Casio's VTOS to boot the board. Let's do that now. And while that's booting, let me give you a little bit of an overview on Integration Workbench. We can connect up to multiple devices under test. We can log all the output out of the device under test or just the commands. You see a command tree here of all the appropriate tests for the system, or you can enter directly into the command line, and you can see that the system is online. In addition to functional testing of the board, VTOS also gives you some configuration commands so you can see exactly how VTOS is running on your board. For example, click on the MMU mapping and you can see the memory map. Click on SD-RAM registers. Here's all the SD-RAM settings. Here's all the SD-RAM settings that VTOS is using to configure the system, and these can be cut and pasted into an email to your firmware team to really help them quickly get their devices up and running. As you can see, the VTOS command tree is organized by devices, and then underneath that we have suites, which are pre-configured for a board, a collection of diagnostic tests, also pre-configured for the board. Here in the case of SD-RAM, we've got a variety of tests, standard walking ones, walking zeros, but also some very interesting tests for burst accesses and bus noise. Diagnostic tests are built up out of test methods. These can be applied to any memory on the board, even inside of an FPGA or on the other side of the FPGA. And test methods are built up out of low-level commands, and this is where you get the lowest level read and writes, peeks and pokes into every register, every cell of memory. These kind of commands gives you access, read-write access to every GPIO as well. The test methods and the low-level commands require input from the operator. Start off with an SD-RAM quick test, and And this runs a basic set of address and data line tests like you might see in a bootloader or a JTAG or boundary scan box. And you see that everything passed here. So with VTOS, you can test memory devices to ensure that they successfully store data without data corruption. You can use the incrementing pattern algorithm to perform a quick pass over a device, storing and verifying a pattern to each address in a range, and then use the marching bit algorithm to really hammer on each address in a range, testing every single bit at each address. VTOS also provides a generic set of commands that you can use to create custom pattern-based tests. So let's run a more comprehensive test, which will put more stress on the system. We'll have to come back in several minutes. Several minutes later, we can see that we have some test failures. In one particular test, we can right-click on that test, execute again, or get a report on the test. And we'll see that within this comprehensive suite, we had failures in the burst test. If we scroll up, we can see many error codes and many expected and actual responses showing differences. So we can cut and paste that error code into our command reference document and look up the error code. And here you can see the description that this error code was generated from our memfull method. These methods can be applied to any memory in the system. Again, shows the parameters, usage, environment variables, and then this particular error code that there was a verify error after writing one's complement data pattern. In the next video, we'll drill down on this error condition and get to root cause.
Let's take a moment and summarize what we've just seen. We've demonstrated a memory test solution that is comprised of commands, methods, tests, and suites. We used a verification environment which was based on Integration Workbench, which we used to communicate with VTOS, the operating system that the device under test was running. Utilizing the verification environment, we quickly located a memory problem. The next step is to isolate that memory problem, and that'll be the topic of the next video. I hope you enjoyed this video. Thank you for attending.